So let's do some probability basics. That's why I like this mug. There's a 100% chance of me teaching you probability. Yeah. So I'm going to start by just introducing you to some of the terms that we're going to be using later on. And the first thing is called a sample space. That's the first one. I think it's important, so I'll do this. So we call it U, and that's just all the possible outcomes. So I mean, it's a fairly simplistic idea, but actually using it, so well, let me just show you. If you flip a coin, for example, I mean, technically we tend to say it goes heads or tails. It depends on where you live, though. There's not always, someone's head on the front of it. But let's just say we call it H or T for flipping a coin. It lands on one side or the other. Well, the sample space then will be this. It'll just be, let's see, it'll be heads. I could just say H maybe for heads and T for tails. Do you see there's only two possible outcomes? So there's your sample space. Okay, your sample space is just HT. All right, not so complicated. If you roll a die, that's something with 6 sides, right? So let's assume it's a nice regular die, and then it's got 6 sides, so it could be a 1 or a 2 or a 3 or 4 or 5 or 6. That's the list of all the possible outcomes. How about if I flip 2 coins? This gets a little bit more complicated, or even more things. So one little trick that I remember learning in school, I thought it was actually pretty helpful, was to draw this sort of almost like a grid here, and you'd say like, okay, there's heads or there's tails here for one of the coins. Well, there's another coin as well, so maybe heads and tails. What you do is you look at where they meet, and you can say, okay, well, I can make a line, kind of going straight up like this and straight up like this. I can make one that goes like this and like this. And where these ones meet, those are intersection points. Those are places where you actually have some solution here. So there's 4 different things that could happen. There's heads on one coin and heads on the other. Do you see why that sort of helps us to tell what it is? So I could say, all right, so it could be, for example, this one right here is heads, heads. So I'll just write HH for, head, heads. All right, well, the other one, let's see if I go across maybe. It could be heads and tails, so HT. What else could I have? Well, I've done this one and this one. How about this one? This is tails and heads, so TH. And there's also TT. Now, the order doesn't matter. Okay, that's actually pretty important. No, or the order is not important. So we actually don't care which one comes first or which, it doesn't matter. I mean, it's helpful if you're a little bit strategic how you decide them, because sometimes they're a little bit more complicated, but the order is not so important. The key thing was just to be able to tell the sample spaces for these. Now, why do we need that? Because now we have the formal definition of a probability. What I like about probability, it's this really cool math tool that allows us to predict the future. So if you sort of know how many things are laid out and assuming chance is even for things, then you can actually start predicting what's going to happen. Now, you don't predict it exactly, but you look at the likelihood of something happening. But that helps us to predict. So we have something, we say the probability is always between 0 and 1. So that's the first really important thing that we're going to say here. So maybe I'll put that here like this. So that is an important point here. So what do I mean by this? Well, we could have like a probability, for example. Maybe I'll write it like this, like maybe the probability of A, let's just say that's how we would write it. Probability of A occurring. Let's say if it equals 1. What does that mean? That means it's 100% likely. That means it's going to happen. Okay, so that's a little bit like this one right here, like this mug, right? There's a 100% chance of me teaching you probability. See, 100% likely. Well, let's say a probability of 0. What does that mean? That means it's 0% likely. That means it's not going to happen, right? This thing will not happen. But I mean, we can have all sorts of other things. We can have probability of A equals, I don't know, let's say 0.5. What does that mean? Well, that means it's 50% likely. So I hope you get the idea. So the way I like to think about the percents, in case you forget how percents work, 50%, what does that really mean? 50% really means over 100. I mean, like in French, for example, we say pourcent. It literally means like over 100. So 50 over 100 is 0.5. So that's how we sort of define percent, because you literally divide it by 100. See, 100 over 100 is 1. 0 over 100 is still 0. 50 over 100 is 0.5. So just so you can remember about percentages. Now, how do we formally define the probability? This is in your formula booklet, but it goes like this. Probability of A occurring. Okay, how do we actually figure this out? Well, we say it's N, A, I'll explain what this means, over NU. This is the formal definition. So this is important. This right here you actually get in your formula booklet. I think I typed that out. There we go. So this is in your formula booklet. So what does this mean? This right here, n, means the number. Okay, so this is the number of outcomes. Let's say. Yeah, in A, I guess. So the number of different ways that A can occur. Whereas this right here is the number. How could I say? You know what I'll say? I'll say total number of outcomes. Maybe that's a nicer way to say it. Total number of outcomes. And remember, if you look at this, why do we say U? Because U is the sample space. Remember, we just learned U is all the different choices. So this idea about the sample space can be useful because do you notice here there were 6 different choices or outcomes for rolling a die, whereas there's only 2 for flipping a coin, once at least. This tells you that bottom number. That's why we are bothering to do that. So this is a really important thing here. Maybe another one I could add could be, maybe I'll write it in red because it's really important. So we could say, for example, that because the probabilities are always between 0 and 1, I'll say 0. Maybe I'll write it like this. I'll write it really nicely so we can sort of see. That's how we basically say the probability is always between 0 and 1. That's a way of saying it. So let's do an example. Now the examples are always really boring with like there's a bag with a bunch of chips or a bunch of different things in there. I just figured, okay, 5 red chips, 3 monkeys, 8 clowns. I don't know why this bag is there. We have to assume that it's going to be equally likely chances. Better would be to make them all, chips, so red, green, blue, whatever. But let's just say, so let's say a bag contains 5 red little pieces, 3 monkeys, and 8 clowns. What's the probability of choosing a clown? It's a bit of a ridiculous example, because if you're actually choosing, you'll probably feel the clown, whatever. But let's just assume you're just picking randomly. What's the chance? Well, the probability of, and I like to, write it with the letters. So maybe I'll say C for clown. So maybe I'll call that right there C for clown. So the probability of choosing a clown, I want P of C. Well, it's going to be the number of outcomes in clown. In other words, how many clowns are there? Well, there are 8 clowns. I divide that by the total number of outcomes. Well, how many outcomes are there? Well, there's 8 plus 3 plus 5. Well, 5 plus 3 is 8. 8 plus 8 is 16. So I got 8 over 16. Now this reduces. 8 divides by 8, I get 1. 16 over 8 is 2. So in other words, I could say that, I could leave it as 1/2, or I could say it's 0.5. Both of them would be correct, just so you know. So just to show you a really simple, maybe dumb example, but just so you can see this will be an answer, so is 1/2. It all depends if you want to use a calculator or not, or whatever. But this is the main idea here. So let's keep going. We're going to have complementary events, like this one here from Parks and Recreation. It's not really from it, but I like the meme at least. I don't know what a complement is at this point. I'm too afraid to ask. So what are complementary events? Those are 2 events. Well, maybe I'll just define what that is. So A primed. That's how we write it. We write with a little prime. And we don't mean, like in calculus, we mean a derivative here, so it's a little bit confusing. If you're doing probability stuff, you see a prime, it's a complement. What does it mean? It means not A. So this is really the key thing. This is the key stipulation. Once we know this, then we know what to do with this, right? So this is a complement. So this complementary event, that is A primed like this. We just mean not A. Well, then we're going to end up with something that's going to be really important. And we can say then that, okay, well, remember we said the probability of A occurring. Didn't we say all the probabilities have to lie between 0 and 1? Well, it's going to be kind of nice because you think about it. The probability of something occurring, let's say it's, well, we'll actually do an example here, plus the probability of it not occurring, that should be 100%. So that's why we write it like this. So we say probability of A plus probability of not A is 100%. And the good news is we can then use this to figure things out. Now I'm formally going to write it down. Most people have no trouble with this. I just wanted to show you how we can use this formal definition. So let's just say we have A, which means it rains today. I live in Denmark. I'm recording this in the autumn. It's probably going to rain today in Denmark, let's say. So let's say the probability of rain today then is 0.6. Then what's the probability that it doesn't rain? See, that's what this means. This means no rain. And most people have an intuitive understanding. You go, oh, 0.6. So if it's like 60% likely to rain, then it's probably 40% likely to not rain. You already have some understanding of this, right? So just to formally play with it, I can say, well, I know that P of A plus P of not A I know that that's going to be 1. And since I know that P of A is 0.6, well, I'm just trying to show you how we can play with the equation just to see we're going to get the same result. If I want to get probability of not rain, well, what do? I do 1 minus 0.6. Well, that's going to be 0.4. So do you see how we can work with this formal definition here, but still we can get the answers, right? We can get, what this says really is that 60% likely to rain. That means it's 40% likely to not rain. Fine. So just so you know, that's how we play with that definition. Now we've got last thing right here. I did this here with the calculator, so I thought I'd do this in a Doge meme right here. I know it's an old meme, but I still like it. It makes me laugh. Plus someone did it with a TI-84, which, hey, that's one of the calculators you can use. The expected number of occurrences. So let's say you figured out some probability. Okay, so you figured out the probability of A occurring. You figured that out, it's probability of A. Okay, now you repeat some experiment. So let's say you figure this out, then you just do it a bunch of times. Well, the number of times you expect this to happen is going to be n times P of A. So this is how we're gonna state the number of occurrences here. So what this means is that if I repeat some experiment, 20 times, then 20 times that probability is how many times I expect that to happen. Let me look at an example here. So we have the probability that a student forgets their GDC right there. Let's say the probability that they forget their calculator to class is 0.2. That means it's 20% likely that any kid forgets their calculator. Maybe it's higher in your class, I don't know. Now the question is, how many students in a class of 23 are expected to have their calculators that day? So see, the key is to just decipher what they're saying here. So probability that you forget is 0.2. Now maybe I'll say C is going to be calculator. Maybe I'll write it like that. Maybe C will be calculator and C prime will be no calculator. Maybe that'll be a simple way to do it. I think that's maybe at least I thought that's the easiest way for me. Calculator. Well then, I can use this idea, right? I can first say, well, what's the probability then of C? Do I know that? Well, I know actually probability of C prime. I actually know this one. I know the probability that they don't have their calculator. See? Forgets. That's going to be the one at 0.2. Well, then what's the probability that they do have their calculator? I'm going to essentially use this idea right here. Remember that probability of A plus probability of not A equals 1. So if that's the case, how do I figure this one out? Well, 1 minus 0.2 is going to be 0.8. Right? So hopefully you'll sort of get that. So I know then that the probability of the student having their calculator on a given day is 0.8. I'm just trying to show you how I figured that out. Okay, it just came from not this. All right, so how many students are expected to have their calculators? Well, now I have what I need. Do you notice that? The expected number, I'll write it down maybe like this. Expected number equals n times P of C. All right, well, what's n? N is the number of times I repeat this experiment. I'm repeating it 23 times because there's 23 students. I'm going to do that times 0.8. Well, you're allowed to use your calculator on your exam, so let's just do that. So what is 23 times 0.8? Oh, that gives me 18.4. Do you see that? So, all right, and this actually would be the answer. I could actually say 18.4 students. It's allowed to be a decimal. It all depends how you want to interpret this result. I mean, it's the expected number. Obviously, you might want to do something with this and maybe round it. You might want to say, oh, I would expect an 18, because sometimes it makes sense to have a decimal. Sometimes it doesn't. So you have to give some thought to what is reasonable. Obviously, this is 18.4 students. So, well, there's 18 entire students. I mean, you can't have 0.4 of a student. So, I mean, you could also say 18 students. You have to just think what makes sense in your context. Because sometimes we might be doing expected, I don't know, number of dollars won. Well, then it can be a decimal. Do you see it? So the decimal answer you get, you have to think and interpret if it makes sense. So when do we use this stuff? Well, we use probability for so much. I mean, we basically use it to predict the future, right? We use this in, gambling, games of chance. We use this in weather predictions. We use this in all sorts of stuff. So this is like ubiquitous. It's everywhere. Okay, so hopefully this helps give you an introduction to probability.